is provided by Nautilus Sports Medical Industries, the Grass Foundation. Additional funding provided by these organizations. The following is a co-production of Hawaii Public Television, the film crew, and Moana Productions.
Long ago on our planet, a design was born. A 1,000 feet under the sea, it has survived the forces of evolution for 500 million years. Aristotle gave the animal its name, Nautilus. Science has called it a living fossil, the last of a line of prehistoric creatures that became extinct with the dinosaurs. Hidden in a dark and inaccessible world, the Nautilus and its secrets eluded man for centuries. Now, we are finally beginning to unlock this world, allowing a glimpse of life in the sea millions of years ago. The Nautilus shell is familiar to many, but to find the animal living within, we travel to the western Pacific Ocean. "400 miles north of the equator lie the tropical islands of Belau, formed by volcanoes and the uplifting of ancient coral reefs. Our journey takes us to the edge of a drop-off, where a shallow reef plunges to oceanic depths of thousands of feet. On the reef top, the sunlit waters teem with a remarkable variety of fishes and other animals. Most of them live in a crowded and highly competitive world. Down the vertical reef face lies a largely unexplored environment, where sunlight and life become sparse. We can go no farther than a few hundred feet using scuba gear, but science allows us to probe deeper. A remote camera continues the journey for us. The camera and light are attached to a specially designed trap and turn on automatically every 2 hours. It descends to a depth of 900 feet. Deep water shrimp are the first to arrive, attracted to the fresh tuna in the trap. Like most deep water animals, they are adapted to locate a new food source quickly. 2 hours later, another creature makes its first appearance. These are the first views of Nautilus in the deep sea. Eventually, more Nautilus arrive, and some find their way into the trap. By recording these pictures at various depths, scientists have discovered that Nautilus are most common between 500 and 1,000 feet deep. An occasional eel is seen, but unlike the shallow waters above, there are few fish here. Most of the inhabitants are crustaceans that scavenge the bottom for food, like shrimp and large crabs. To get a closer look at the elusive Nautilus, they are brought to the surface. On the way up, the captive animals are exposed to dramatic changes. The darkness gives way to full sunlight. The water warms noticeably and the pressure drops tremendously. But somehow the Nautilus survive, just as they have survived over eons of time. How they manage this is a puzzle, and man is looking for the pieces.
Still. Look at that. Oh, recatch. Let me see the piece. Look at that.
The discovery that these ancient deep-sea relics can be trapped and collected opens the door to scientific investigation. The animals are sensitive to temperature and prefer cold water. Packed in insulated coolers, they are kept healthy for a 5,000-mile trek to their new home, the Waikiki Aquarium in Hawaii. Here, careful control of temperature and light keep the Nautilus alive and provide a rare opportunity for a detailed look at the creatures. Nautilus is a mollusk and is related to many familiar snail-like animals. Some are highly prized by shell collectors. The tiger cowrie slowly grazes the reef, feeding on algae. It is able to detect chemicals in the environment using antennae on its head. It breathes by sucking water in through a funnel-shaped siphon, an organ all mollusks share. Other relatives have lost the external shell during evolution. Like the cowrie, the colorful Spanish dancer browses the reef surface for food. Unencumbered by a heavy shell, this sea slug need not travel at a snail's pace. Not all of the marine snails are grazers. The feeding habits of the ton shell give new meaning to the word gluttony. It bears down on a sea cucumber, a relative of the starfish. While related to the snails, the Nautilus is a member of the most advanced class of mollusks, the cephalopods. Its members include squid, cuttlefish, and perhaps the most familiar of all, the octopus. Once feared as a monster of the deep, we now know it to be a complex, highly intelligent animal. Its structure illustrates the basic design of the modern cephalopods. Their muscular arms are covered with several hundred powerful suckers. These are some of the most effective grasping and manipulating organs in the animal kingdom. Breathing and propulsion are accomplished by pumping water through a tubular siphon. Cephalopods are well known for a highly sophisticated nervous and sensory system. The eye is surprisingly similar to the human eye, with a lens that focuses sharp images. Another cephalopod with a sharp image is the cuttlefish, whose skin pulsates like a neon sign. These extraordinary color displays may serve as signals between animals. The spotted coloration and inflated posture is a warning that this octopus is about to be challenged. Competition for living space on the reef can be fierce, and no octopus will give up its burrow without a battle. But combat with a powerful 8-armed opponent is approached with extreme caution. As you would expect in a highly intelligent animal, each octopus assesses the strength of the other before committing to fight. A final weapon is employed, a sharp beak hidden beneath the attacker's body. These remarkable animals represent the pinnacle of mollusk evolution, while the Nautilus appears to be a strange case of arrested evolution. The creature's movement seems sluggish, and it is stuck with a fixed color pattern. The expressionless eye has no lens, and at best operates like a pinhole camera, forming rudimentary images. Radiating from the head are 90 tentacles, far more than any other cephalopod. Like its relatives, the Nautilus tentacles surround a powerful parrot-like beak, used for tearing and cutting prey. The tentacles' grasp can be unyielding, even though they have no suckers and appear smooth in texture. Yet appearances can be deceiving. Viewed under a scanning electron microscope, a series of ridges is visible. These ridges give the tentacle its adhesive grasping power. Scattered with cells that detect smells in the water, the tentacles also act as sensors. While the living Nautilus has been studied only in the last few years, the delicate beauty of the spiral shell has been admired for centuries. These internal chambers are unique in nature and unbelievably old. A 40-million-year-old fossil, and that of a young Nautilus. Still a perfect match after millions of years. Until recently, scientists misunderstood the function of the shell's ancient architecture. It was once thought the shell operated like a submarine, by flooding chambers to descend and emptying them to go up. Dr. Peter Ward takes X-rays of baby Nautilus as they grow, providing an inside look at how the system actually operates. The body of Nautilus occupies the first large compartment. The other chambers are sealed and connected by a thin strand of living tissue called the siphuncle. It is through this siphuncle that Nautilus regulates the content of each chamber and controls its buoyancy. Most of the chambers are empty, except for a gas similar to air. However, a fluid is present in the most recently formed chambers. As the animal grows, it becomes heavier. To avoid sinking, it compensates and loses weight by removing some of the chamber fluid. Growth continues. The animal slides forward in the body chamber, and a new septum is formed. This creates a new chamber full of fluid, which will be emptied as the cycle repeats itself. This series of X-rays shows a young Nautilus growth over a 7-month period. As the animal grows, new chambers are being formed and old ones are being emptied. In this way, the Nautilus maintains a weightless condition in the water so that it neither sinks nor floats and always remains upright. Having achieved the ability to hover, the Nautilus must actively swim to move in any direction. Like all cephalopods, it does this by forcing water through the siphon, traveling by jet propulsion. The evolution of the chambered shell allowed the ancestors of the Nautilus to become the first swimming predators in the prehistoric sea. When dinosaurs roamed the land, the marine environment may have looked like this. The most successful predators were shelled cephalopods. For 300 million years, they dominated the shallow seas in many bizarre forms. Then, along with much of the animal kingdom, they suddenly became extinct 65 million years ago. Only the Nautilus survived today. This underwater dinosaur might be an evolutionary dead end, traveling the road to extinction. However, a different picture may be emerging from studies in the wild, where scientists are searching for clues to the survival of Nautilus. Dr. Bruce Saunders and his assistant have been trapping Nautilus in the Indo-Pacific for many years. The specimens they capture are quickly returned to the sea. Each animal now bears the unmistakable sign of its brief contact with man, an ID number which will allow scientists to identify each individual for years to come. Some of those released will be caught again. It is these recatches that interest the scientists.
Let's take a look at that recatch. It's number 880. 880? We used to use these tags before we realized they were coming off. It's amazing if that stayed on.
Dr. Saunders has numbered thousands of animals. Each one is carefully measured and sexed, a procedure requiring a slight invasion of privacy.
MBI female. Excuse me, ma'am.
Over the years, the records reveal new insight into movement patterns, population size, and growth rates.
All right, that's 2798. That's not a particularly large male. The males are almost always quite a bit larger than the females.
Animals are recaptured many times, often in the same location. But some have been recorded to travel over 100 miles in 1 year, an impressive trek for a supposedly sluggish animal. Nautilus was once thought to be rare, but these trapping studies indicate otherwise. As research continues, there is mounting evidence that Nautilus is a successful inhabitant of the deep reef drop-offs throughout the Indo-Pacific. To achieve success in this habitat, Nautilus developed growth and reproductive methods vastly different from other cephalopods, such as this cuttlefish. She illustrates the bizarre reproductive pattern of cephalopods, which some have called the Big Bang method. She searches for a safe place to lay her eggs. A few weeks ago, she mated, the first and only sexual experience of her lifetime. After laying a clutch of several hundred eggs, she withers and dies. Her entire life cycle is over 1 year after hatching. For Nautilus, sex and reproduction are not terminal. Mating and egg-laying occur frequently throughout their lifetimes, which may be longer than 20 years. A few large eggs are laid. Little is known about Nautilus development, but a breakthrough occurred recently when Dr. John Arnold discovered a living embryo in an egg laid in the Waikiki Aquarium. This is the first embryo ever seen by man. No one knows where or at what depth the eggs are laid, but studying the movements of the adult Nautilus may provide clues. The red beeper attached to the Nautilus is an ultrasonic transmitter. Its signal allows scientists to track the Nautilus over a 7-day period. The rain clears and the biologists relocate the signal. The pulse rate of the transmitter varies with changes in water pressure, allowing the depth and location of the animal to be determined accurately. The crew soon appreciates the Nautilus jet propulsion as they discover the travels involved in a day in the life of Nautilus. During daylight hours, the animal is tracked moving over a mile in a 6-hour period. Its depth ranges from 600 to 1,200 feet. At dusk, an astonishing vertical migration occurs as the mollusk moves up to waters as shallow as 200 feet to cruise the nocturnal reef. This amazing flexibility in exploiting different habitats may be one key to the survival of Nautilus. Why Nautilus comes up here is unknown, perhaps to lay eggs or to feed, but it makes these journeys only during darkness, with which its poor vision and keen sense of smell are designed to cope. This is also a time of rest and inactivity for many reef fishes that might otherwise make life difficult for Nautilus. As long as it's dark, a Nautilus is safe here, but when the reef awakens, the Nautilus would quickly find his jet propulsion outclassed. Fishes are the new mobile predators of the sea, and their agility is unparalleled. Being superior competitors for food and other resources, they replaced the ancient shelled cephalopods on the reef. Exactly what happened to Nautilus ancestors is a question that has caused much debate. Possibly the advanced fishes drove them to extinction, or a great environmental catastrophe wiped them out, and the fishes merely took over. Nautilus may have escaped disaster by retreating to the depths. Far from being doomed by an antiquated design, it is well adapted for life in this cold, dark refuge. The eye may be lensless, but it is sensitive to the wavelength of deep water light. Hunting in such dim light requires acute sensitivity to scent, particularly where food is scarce. This is a feast or famine world, and Nautilus must be equipped to seize the opportunity. A shrimp sits motionless, but Nautilus detects its scent in the current. Attempts to get free are hopeless in this bed of tentacles, and the beak finishes the struggle. A shrimp is much more to the Nautilus than a tasty treat. Through a diet of crustaceans as well as their molts, Nautilus obtains calcium, which is necessary for shell growth. Is Nautilus a living fossil, a creature from the past? Its fossil record supports this, and it does have primitive traits. But these traits work well in its habitat, and it may have evolved them specifically to use in the depths. It lives where it has few predators, and has coped impressively with any pressures to change. If it is cheating evolution, it is doing it with style. New populations are continually being found. Yes, there is new life yet in the old line.
Major funding for this program was provided by Nautilus Sports Medical Industries, the Grass Foundation. Additional funding provided by these organizations: